Hi, good morning. My name is Smita Jairam. I'm from Hewlett Packard Enterprise, and today I'm going to talk about transforming storage for containers, stateless and static, to stateful and agile. The agenda for today is first we'll see why containers are becoming so popular. Why is it a platform on the rise? Okay, what is the transition that's happening now, which is stateless to stateful and static to agile? What are the challenges of persistent storage and what storage industry has to do to address these challenges? Then some introduction into the container orchestrators and the storage plugins. Then some work on what HPE has done in this space and some takeaways. So this slide is basically gives a very good abstraction of the evolution that has happened with respect to application development. Initially, the applications were monolithic that were running on physical servers. They were based on the client-server model where the backend used to run on a server that is on a physical machine, and the server process was actually monolithic in the sense that the web tier, the application tier, and the database were part of the same program. The clients used to connect to these, and it was very hard to scale these because they were more running on physical resources. Then came the era of virtualization, where hardware was actually hardware was virtualized, and these three layers, which is the web tier, application, and database, started running on separate virtual machines, all sharing the same hardware. Further on, there was the internet scale application development, where the individual tiers or components started running on different containers. The containers were stateless. They were easy to be created and destroyed and moved around. However, there was no state maintained by each of these tiers. They were able to scale horizontally in the sense that multiple of these triplets or applications we could deploy multiple of these and the scale could go horizontally. Finally, now the industry has kind of realized that each of these tiers can actually run as microservices, wherein the scale need not be horizontal. That is, if there is a scale needed in one tier, that tier alone can be, multiple instances of that tier alone can be created and scale can be achieved. But the challenge here in the microservices architecture is basically that every container comes up, runs a service, persists some data, and dies down so that multiple of these iterations can continue. So whenever there is data that persists, the storage layer has to be capable of managing this data and making it available as and when needed. The other advantage of the microservice based architecture is basically the build, ship, and run. That is, the developers should be able to build, deploy, and make it run anywhere. We'll spend a couple of minutes on introducing containers because that's what we're going to talk about today. Containers are a lightweight operating system level virtualization, and they are a standalone piece of packaged software. So some history on containers was that containers was initially launched by the Linux container OS. So Linux containers was the first form of containers that ran. Docker actually assimilated a lot of manageability features into this and called it as a Docker container. And then came the container orchestrators like Kubernetes and others who actually brought in the orchestration layer. And probably one step further is there could be federations of these uh, orchestrated clusters. So that's how containers have evolved. And they are basically processes with isolation, and they are shared resources, and they actually uh, work on layered file systems.